Well, my mom's neighbor.
Okay, howdy ho, everybody. Welcome to another exciting episode of MIS 310. Okay, today we're going to talk about Chapter 5. But before we do that, because someone's requested, hey, what about giving us some guidelines for our project? Yes, sir.
I just thought of something. How do you guys decide the letters, or the numbers that go next to the course names? Like 310 and 420?
It's somewhat random.
Okay, I was just curious.
In theory, there is a basic hierarchy of the higher the number, the more difficult the course.
So like 475 could have been like 490.
Graduate classes above 400.
Yes, they're typically they start at 600.
Okay. What's
500 are introductory graduate courses.
So you take that as a graduate student?
Yes. So, for example, if you want to get an MBA and you're not a business major, you have to take some 500 level courses to cover the basics of the curriculum of a business major. But as a business major, you don't have to take those. And it's only 36 hours to the master's degree, which is not too long. Graduate courses are harder, so you only take 9 hours a semester typically instead of 12. I completed my MBA here, started in June 2nd, or first summer term. Did the 2 summer terms, did fall, winter, or spring, and the next 2 summer terms and graduated in August.
Are they really harder? Or are they just...
Yes. And then I went on to a doctoral program.
Okay.
A lot of papers?
I like it.
More, yeah. What?
I was talking about tomatoes.
Tomatoes. You say tomatoes, I say tomato. Okay. You will notice there is a new folder entitled Project Files. Now, let's turn that off. Now, if you open that folder, you'll find a long list of files. The first one is a zipped container of all the files. The next one says 1, followed by 2 and 3. All 3 of those are project overview templates, more or less. I suggested you probably use which one? Number 1, inside. Named it number 1. Number 2 has a really good risk analysis table at the end. So I suggest you look at that. And then there are all these other supplemental files that you can look at if you would like to. Here is number 1. So it has an introduction, and then you start with the current system analysis and more definitions of that, or how you're going to proceed with your analysis, the overview of the current system, more analysis of the current system, performance analysis of the current system, information and data analysis, economic analysis, security, or control and security analysis, efficiency analysis, service analysis, miscellaneous analysis, and then recommendations. So here you talk about that, and a conclusion, And then appendices if you want to add more, and it's only 23 pages. So that means as a group you're going to produce kind of a big document. The last time I taught this course, it was the spring of '99. So it's been a long time. Back then, students typically would turn in a project notebook, 3-ring binder, 3 inches thick, full of stuff, analysis of the project. I don't want you to do that much. No. No, laptops are really pricey in '99.
So we're like presenting something and then we have to turn something in.
Yes.
Wait, your templates are just like suggestions and stuff, right?
Yes. General guidelines for what you should include.
Okay.
So I have this meeting. Okay. Mind tap. So I went through and added due dates all the way to the end of chapter 12. Okay, so last night Alex said the tests weren't working. I tried to test. They seem to be working now. Okay, then there are some introductory parts here that you should look at in preparing your case. And then there are lots of videos and assignments. So, Hannah.
Are we doing just the 12 chapters or is there more chapters after that?
No, there are videos after that. And so I'm going to choose some of these and allow you the opportunity to do something.
So after we're done through 12,
No, these will be added, so you'll
Oh, now
do
it
them.
again.
Okay,
What?
So week 15 is
Third
oh god. I feel like PTSD from this third normal form.
database.
It is.
Decision table, third normal form.
Please no.
don't do that.
Don't do that.
I'm lost. I have no idea what you're saying. What?
Third normal form.
Last semester.
Don't
It's the
touch it.
worst. Please don't do that.
Yes, you get to do it.
Yes! I actually did get on that.
I actually did too. I got like a
Oh,
nice
I think I remembered from last year.
I had no idea what was going on the entire semester. I didn't get my class.
Okay, so here
Oh, PRD.
there are videos.
Welcome to this video learning session. When you complete the session, you will be able to create entity relationship diagrams, also called ERDs. In this session, you'll learn what are ERDs and why are they important, how to create ERDs, and how to use a case tool to create ERDs. An ERD is a graphical model that shows how entities are joined together to form a relational database. You'll learn more about relational databases in other learning sessions. Let's view some examples of relationships between entities. The relationship between zip code and area is 1-to-1. One zip code identifies one specific area. The relationship between team and player is 1-to-many. One team can have many players, but a player only plays for one team at a time. The relationship between person and project is many-to-many. One person can be assigned to many projects, and each project can have many people assigned to it. You can draw an ERD freehand or use software tools. In these examples, we'll show entities as rectangles and relationships as diamond shapes. In a one-to-one relationship, one office manager heads one office. One vehicle ID number is assigned to one vehicle. And one social security number is assigned to one person. In a one-to-many relationship, one individual can own many automobiles. One customer can place many orders. And one faculty advisor can advise many students. In a many-to-many relationship, one entity can match many instances of the other entity. For example, one student can enroll in many classes, and one class can have many students. One passenger can reserve a seat on many flights, and one flight can have many passengers. One order can list many products, and one product can be included in many different orders. In a many-to-many relationship, the entities must be joined by another entity, called an associative entity, which identifies and describes that particular combination. For example, a registration stores information about a specific student in a specific class. A reservation stores information about a specific passenger on a specific flight. And an order line stores information about a specific product in a specific order. Suppose you have a sales system where one sales rep serves many customers. One customer can place many orders, and one warehouse stores many products. These are one-to-many relationships. However, order and product have a many-to-many relationship, because one order can have many products, and one product can appear in many orders. So, we need an associative entity called order line that identifies a specific product in a specific order and stores information about that particular combination. Here's how the sales system might look in Microsoft Access. Notice the associative entity, order line, that joins the order entity and the product entity and stores information, such as the quantity ordered. In Part 3, you'll learn how to use a case tool to create ERDs. A case tool, like Visible Analyst, can display the entities and the relationships between them. This simple example has two entities, doctor and patient. We clicked the entity symbol on the menu bar, placed it on the page, and labeled it Doctor. Next, we created the patient entity. The relationship between doctor and patient is many-to-many. One doctor can see many patients, and one patient can visit many doctors. So we need to join doctor and patient using an associative entity called appointment. To create the new entity, click the associative entity symbol on the menu bar. Place it on the page, and label it Appointment. Notice that the associative entity symbol has a diamond shape inside the rectangle. Each record in the appointment table identifies a specific doctor, a specific patient, and stores related information such as date, time, and scheduled procedures. However, no additional data, such as the doctor's name or the patient's name, address, or insurance information, needs to be entered in the appointment table because it already is stored in the doctor and patient tables. The last step is to add lines that join the entities. Now we have a relational database that stores data in 3 separate tables. The associative entity, called appointment, joins the doctor and patient tables in a many-to-many relationship. A relational design improves data quality and consistency because data is entered and updated in only one place. You'll learn more about data design in other sessions. In this session, you learned what ERDs are and why they are important, how to create ERDs, and how to use a case tool to create ERDs. For more information, you can refer to the textbook or your student study tool. Now it's your turn to apply your skills and check your work. For background information, tasks to complete, and sample answers, go to the Management Information Systems CourseMate at www.cengagebrain.com. Select this text and navigate to the video learning sessions. Thanks for attending this video learning session.
Okay, the next part is your turn. So here, we're going to apply our skills and check our work. So you're supposed to draw an entity relationship diagram. Student has an advisor. An advisor can advise many students. Each advisor has a parking spot. Each student can take up to 6 courses. Each course has up to 20 students. Several teaching assistants share an office. Wow! Yes, sir.
I tried to install Visible Analyst earlier.
Yes.
It said that the license you gave us had already been used and can't be used on more than one machine.
Okay. I will email the publisher and see what they say. Let's work through this problem. Let's go with A. For each statement, indicate the relationship, whether it's one-to-many, one-to-one, one-to-many, or many-to-many. Okay, A. Student has an advisor.
You didn't finish it, Nick. Damn it.
I'm sorry, what?
It's one to many.
One to many.
Many to many.
Is that right?
What is it?
Relation.
Many to what?
Okay. So, one student has one advisor. One advisor has... Okay. So that's A. What's the first line? Okay. An advisor has a parking spot. Okay. Next line. Student can take up to 6 courses.
It's a many.
So one course has many students, and one student has many courses. Okay, so we learned in the video that we should change this into what kind of relationship? Associative. And the way we do that is we draw a circle or a square, and then we make it like that. So Justin, what would we call this? Okay, and so what's the relationship between student courses and student? How many student courses, how many of these records will there be for each student?
6.
So which side's one, which side's many?
Student is one, student course, student courses, many students.
So one of these will have many of these. And same thing down here. One of these will have many of these. And we actually said it was limited to 20, but we don't do 1 to 20, we do 1 to many. Okay. Several teaching assistants share an office. Okay, so one teaching assistant has how many offices? 1. And one office has how many teaching assistants?
Many.
There you go. So we have the associative entity there. So that would be the answer to this. Was that hard? Yeah, brand new, right? You've never seen this before.
Did we get credit for that?
If it was an assignment,
Can we make,
if I make it an assignment,
we
then,
just did it, so we should all get credit.
well, no, you have to turn it in before I grade it to give you credit.
I tried.
What does this download do for us, I wonder? Says it's downloading. Ah, just downloading the assignment so you can do it offline. Okay, so what would we do in the turn-in part? So you choose file upload. Okay. Same as all the others. Okay, let's talk about a few of the slides, and then we'll come back and look at another video or two. Okay. One of the things that you're going to see as a recurring theme is the difference between logical and physical. Because the physical on the computer is not logical to us. Right? So we create something, it's stored on the hard drive. Where on the hard drive does it reside? That's its physical location. Can we see it on the hard drive? Only in the form of a directory entry, right? Where it says, oh, it's located here. Do we care what track, sector, record number it's stored under? Do we care about the physical address of the object we store? Thank goodness. No! Because we don't need it, because we deal with it at a logical abstraction. So we deal with the file just by its file name. So we don't have to deal with the physical part. Okay, but when we move to this level, we start looking a little more at how the physical is going to be, but we're still looking at a logical abstract. Okay. So, first up for bid on our data and process modeling tools is the process modeling tool known as a DFD, or Cheyenne. What's the DFD stand for? Second bullet point. Let's all say that together.
Data flow diagram.
Is a DFD is a
Data flow diagram.
okay. Guess what you're going to learn to hate? Data flow diagrams. Okay, so we look at a system and we begin at a very abstract level. The top, we call it 0. And then we take 0 and we divide it into pieces and we number them 1 through whatever. And we take each of those pieces and we divide those into 1.1 through 1.n, whatever that is. And if we have to divide any of those, we call them 1.1.1 through 1.1.n and 1.2.1 to 1.2.n. Real fun. But that way we can look at stuff. Now, what are the 4 basic symbols? So, we have the Gaines and Sorensen symbols, which are the ones that we would use. And then there's the Jordan symbols. The 2 guys who first wrote papers on this topic and came up with a diagramming technique. And so they have been adopted. The textbook uses these. Okay, so we have processes, data flows, data stores, and external entities. So what's a process look like? A rectangle with rounded corners and a line across the top. And typically above the line, we will have the number of that DFD. So, for example, apply payment could be 2.1.3. Okay? The data flow, the line has an arrow on one end, only one end, and that indicates the flow of information in one direction. Data store is our database, our files, where we're going to put the records, and so it's simply a rectangle, well, a sideways U with an extra bar on it. And then an entity, an external entity, is something that relates to our system but is not internal to the system, such as the customer. Okay, so here are fun things about process symbols. We must have at least one input and at least one output. So if we have a process that doesn't have an input, what would we call that? Something that can magically do stuff with nothing to do, with no inputs. There's a name for it. We'll get there in a minute. I don't remember what it is. And if we have a process that just has stuff coming in, but no output, we call that the black hole. Because, you know, thing in space that sucks stuff in and never lets it out. Okay, so each process has business logic that transforms data. So the process is the general IPO model, right? Inputs, processes, and outputs. So it has to have an input, it does something to it, and then it has an output. Because if there's not a process, we don't put one there. Now, we identify it with a name, and the name is a verb. So, apply rent payment or calculate commission. Okay, so a DFD process symbol sometimes is referred to as the black box. It magically does something, but we don't know what that is necessarily just by looking at the process. We hope that the name gives us a good idea of what it's supposed to do, but it doesn't really tell us how it does that. So here are some examples. So we can have multiple inputs to create a single output, or a single input to create multiple outputs, or our outputs can be inputs to another process. Okay, so we have the top one, which is spontaneously generating outputs, right? There's no inputs. They're just outputs. Then we have the black hole. And then we have the gray hole. A gray hole is one where it does something impossible with the inputs. So for example, unless I graded you based on age, I could not take your date of birth and give you a final grade. Because date of birth should have no impact on your grade, other than I've found there is a correlation with age and higher grades. The older you are, the higher grades you typically receive, unless of course you have extremely mediocre standards. If you only want a C, I'll just give you a C.
If that's the case, I'll leave right now.
Okay. Like I said, don't let the door hit you. Okay, data store symbols. Self-explanatory. It stores data. It doesn't tell us any details about how the data is stored, where it's stored. It just says, here's the name of something we're going to store. Now, a store must be connected to a process with a data flow. So we can't connect data stores together. We would still have a copy process in between if we were trying to do that. So here are examples of correct and incorrect ways of looking at data stores. Entities. So entities are objects in the outside world that somehow our process is going to interact with. Now, that external entity could be another system. So, for example, if we had a payment system, we could have a bank, which would be an external entity that the funds were flowing from to our payment process system. Or if we were accepting a credit card payment, the credit card company would be an external entity that we are sending data to and receiving data from. So here are examples of that. Okay, so here's some things to keep in mind. General guidelines that are allowable and not allowable. So we can have a data flow to and from processes, to and from external entities, and to and from data stores. We can't have stuff flowing from one external entity to another external entity. It needs a process in the middle. We don't take stuff from an external entity and store it. Again, you've got to have a process in between. And as we said earlier, data store to data store doesn't work. We would have to have a copy, at least minimally a copy process in between. Okay, so as I said, we're going to learn to create a logical set of DFDs. So, number one, review those guidelines. Number two, then we apply the guidelines to create DFDs, and it's a three-step process. So first we draw the context diagram, and the context diagram is number 0. Okay, I'm sorry, it's level 1. We'll review this in a minute. So we don't want to have our lines cross if we can at all avoid it. We want to rearrange our symbols so that data flow lines don't have to cross. We want to give everything a unique name, and then the referencing number system I talked about, and make sure that the model is accurate, easy to understand, and users can understand it. Okay, so here is the context diagram. So what kind of system is this?
Data flow diagram?
Okay, but what is the system that it represents? What would we call this type of system?
The grading system.
Very good. It's that process in the middle. So this is a grading system. And this process is the highest level. The contextual level is level 0. So I was right while ago. So we number this 0. And we're going to begin drilling down and making all of the pieces. Bless you. Okay, what are external entities here? There are 3 of them.
Student, instructor, and student record system.
Okay. Are there any data stores?
No.
Not at this level. We don't illustrate them. So, as it says here, these are just label blocks. These would not be on a DFD diagram. These are just here for your education. So we number this 0, and it is the entire grading system. Okay, so that's step 1. We draw a context diagram. So this one is an order system. So we have more external entities. We see more data flows. All of the data flows are labeled. And what does the label tell us? Everything about the data flow? No, it just gives us a general indication of what's going to be flowing. So we have a customer. The customer places an order. If there's something about the order we can't process, then we would send information back to the customer saying we reject part or all of the order. The order system sends an invoice to the customer, and the customer sends us a payment. So the salesperson gets a commission, the bank gets a deposit, and accounting gets the receipt of cash. The warehouse gets a picking list and sends back to the order system information about how the order was fulfilled. Okay, so now we start breaking that diagram down into its component pieces. So, here is level 1 again. Overall, this is our order processing system. So again, we have the customer, the warehouse, accounting bank, and sales department. Only now we're breaking that order into 3 components. Fill order, create invoice, and apply payment. So those would be the 3 parts of our DFD with associated information flows, and now we're adding a data store. Okay, so let's look at this data stored accounts receivable. So when we create an invoice, we store a copy of the invoice as well as send a copy to the customer. When the customer returns his payment, it goes where? It goes into the payment, apply payment process. Is this simple and clear? Do you understand how we take this and divide it into these 3 separate processes? Because this is what you have to learn to do in this class. Take a process, grading system, and figure out how to break it down into the component parts. Or this is a simple example that we're all familiar with. We all have purchased things. Now, what do we call this process? We call this process creating exploded views. So, level 0 diagram explodes into this first level diagram. How do we know it's the first level? Because it's labeled 1, 2, and 3 with no periods. So, the diagram above it is called the parent diagram. And so this, the parent of this diagram, is the context diagram, and this is the child of the context diagram. So, as we begin to take each of these processes now and explode them, we will turn them each into a separate diagram. So we have the context diagram and then this first level diagram, but as we go below this level, typically the diagrams start getting too cluttered, so we break them into separate pages, separate diagrams. And again, how do we know what's related to what? The simple numbering system. So the next level, we're going to take process 1, which is order fulfillment or fill order, and we're going to break it into its component processes and data flows and data stores. Now, there may be data stores. We got to store that order somewhere, right? But it is not illustrated on this diagram. So as we get into the lower levels, we will add additional information. The bottom level is called the functional primitive level. So when we hit the bottom, we're back at the primal level. Okay, so step 3, step 1 is context, step 2 is the diagram O, and step 3 is to draw all of the lower level diagrams. Okay, so what do we see here? What numbers? Brenda, what numbers are these processes? Above the line in the process, what symbol is the process? You can't see? You want to borrow my glasses? I left them on my, probably wouldn't work anyway. Tyler, you want to help her out? If 1.1 gets exploded, how will it be numbered?
1.1 point.
Yes. 1.1.1, 1.1.2, etc. Okay, so we have a customer. He sends us an order. What do we do first?
Verify the order.
Very good. How do we do that? We don't know yet, do we? So maybe this data flow here where we look at product details. Okay. And so if we have the products in stock, then that would be verifying the order. If not, we're going to reject the order and prepare a notice to send back to the customer. And we're going to update the customer's credit history. And we have credit history coming here. We're not showing an update of the credit history here. All right, that happens somewhere else. So what you need to do is what? Study this to make sure you understand each of the parts. Now, one of the underlying concepts are that they have to be, as it says in bold, level and balanced. So, leveling is the concept of using an increasing series of detailed DFDs to describe the information system. So we do that using three terms: exploding, partitioning, or decomposing. Okay. So here is level 0, and here is 3.1. So we're taking this and we're exploding it. Now, we have the external parts to this process identified by this data store and these external entities. And we add a new data store right there. So this is how we would do it using Visual Analyst. And I'll have to get us licensed for that, figure out what we have to do to get it. Okay, the next part of the chapter starts talking about data modeling. So we'll stop here and go back to the Vividos, as my grandson would call them.
Welcome to this video learning session. When you complete the session, you will be able to create DFD symbols and diagrams. In this session, you'll learn about DFDs and how to use them as modeling tools, how to create and connect DFD symbols, and how you can use a case tool to create DFDs. The letters DFD stand for Data Flow Diagram. DFDs are modeling tools that show how a system transforms input data into useful information. DFDs contain 4 symbols called processes, data flows, data stores, and entities, also called external entities. Here's a typical DFD. The rounded rectangles show processes. The flat rectangle shows a data store. The shaded boxes show entities. And the arrows show data flows. First, let's get familiar with DFD symbols. We'll start with processes. A process performs one or more tasks or functions. Each process gets a number and a descriptive name. To function properly, a process needs one or more inputs and one or more outputs. Here's an example of input and output data. The apply payment process receives invoice amount and payment data and produces output called account update. A process can calculate sales trends, reorder inventory when supplies get low, or verify a customer's credit status. We can use a flowchart to show what goes on inside a process. A process can contain many other functions that are not visible until you open the process and look inside. In this example, the check for overtime process determines whether an employee worked more than 40 hours. If so, it runs an internal process called calculate overtime pay. The check for overtime process has weekly hours and pay rates as input data and produces overtime pay as output data. A data store symbol represents data that is sent to or received from one or more processes. For example, instructors save student test scores to calculate final grades, and companies keep payroll data for year-end W-2 forms. An entity symbol represents someone or something that interfaces with the information system. In this example, the entity is a customer. An entity can supply data to the system or receive data from the system, or both. In a school registration system, entities might include student, registrar, instructor, and course. In a corporate sales system, entities might include customer, sales rep, accounting department, and warehouse. A data flow allows data to move from one part of the system to another, like a cable in a communications network. Data flows can handle input, output data, or both. A data flow can include just one data item, such as a checkout registered total amount, or it can include a large set of data items, such as class grades for an entire semester. Now that you're familiar with the DFD symbols, you need to use them properly. For example, a process must have both input and output. Here are some correct examples. On the other hand, here are some incorrect examples. In the first example, there is output but no input. In the second example, there is input but no output. In the third example, there is input and output, but the input could not logically produce the output. There are rules for data stores, too. Normally, a data store must have at least one input flow and at least one output flow. Here are 3 correct examples. But these are incorrect. In the first example, a data store must connect to a process. It cannot connect directly to another data store or to an entity. The next 2 examples are incorrect because a data store must have input and output, unless the data is fixed, like a tax table. Here are 4 correct ways to connect entities. An entity only can connect to a process. Notice that an entity can send data, receive data, or both. These examples are incorrect because an entity can't connect to another entity or to a data store. Here's a recap of the rules. This might be a good time to pause and review them. In Part 3, you'll learn how to use a case tool to create DFDs. The letters CASE stand for Computer Aided Software Engineering. Case tools are powerful programs that analysts use to speed up the system's development process. Let's start with a diagram that was created with drawing tools found in Microsoft Office applications. The diagram shows part of a payroll system. The 3 processes are calculate base pay, check for overtime, and run payroll. The three data stores are work hours, pay rates, and total payroll. The two entities are an employee who receives a pay stub and a bank where direct deposits are made. This example shows how to use and connect DFD symbols properly. Now we're ready to create the same DFD with a case tool called Visible Analyst. First, click the data store symbol, place it on the screen, and label it Work Hour Data. Then, add a second data store and label it Pay Rate Data. Next, we need two processes: calculate base pay and check for overtime. With these symbols in place, let's see how data flows between the process and the data stores. Calculate base pay and check for overtime both use input data flows called weekly hours and pay rates. When you connect the symbols, Visible Analyst prompts you for a name for the data flows. We have input. What about output? The output flows are called base pay and overtime pay. Both data flows go to the total payroll data store. The total pay data flow becomes input to the run payroll process, which produces two outputs: a pay stub to the employee and a direct deposit to the bank. This example shows how case tools can help you model and document a system. In this session, you learned what DFDs are and how to use them as modeling tools, how to create and connect DFD symbols, and how to use a case tool to create DFDs. For more information, you can refer to the textbook or your student study tool.
Okay, so what are we supposed to do? We've interviewed users. We've created an entity called customer. It has three processes: handle order, generate invoice, handle payment, two data stores: price file and invoice file. Identify those data flows and create the DFD. Suppose you wanted to show an order, which is an output data flow from the customer entity into the order handler process. Okay, so we will draw that. Wow, lots of stuff here, huh? Okay. So this is a nice format for the information. It has it all laid out for us. All we got to do is draw it. So let's do the first one. We have a process called order. Justin, how do we draw a process symbol? Nice try, but a square?
Okay, round it.
Around it. beautiful, isn't it? That's just beautiful. Kind of like a square, only it's got rounded edges. So I guess we could draw a square and put the rounded edges. Okay, it's an order. So we have a flow to and from. What's the flow from, Michael?
Customer.
How do we draw a customer? What is a customer? It's an entity.
Well, we gotta draw a line somewhere.
Not yet.
Well, we could.
Well, we will, but not yet.
Well, we'll just draw another little box thing like that.
No,
Rectangle box thing with round edges.
no.
No round edges.
Why not? Why doesn't this have round edges?
These aren't all my words, by the way.
Oh, you're getting help from Big Green behind you. Why not, Evan?
That last video made me sleepy.
No, Evan. Drew. The video puts you to sleep.
Yeah, can we
Her
actually-
nice soft voice. She
can we dim the lights?
play a little mood music.
I don't need that.
How about, let's see, my wife listens to,
Waterfalls?
no. UCLA has some podcasts of guided meditation that help you go to sleep, actually.
To replace it?
Yes, on your phone, just look up guided meditation podcast. Okay, this is a what? What's it say right here behind the word customer?
Entity.
Right.
You can't- so those
An
are,
entity is a square
those are
versus a process which has,
squares.
okay, a rectangle, whatever. Okay, so
Let's get it right.
what do we have next, Hunter?
2.
Yeah, where does it go to?
You know, the order kind of
And order.
Okay, and what kind of symbol should I draw?
Process. Is that the diamond one?
No, it's
Square with rounded corners and a line through it.
I like using that shape as a bed instead.
a bed. Okay, a mattress. We'll call it a mattress symbol.
What's the mattress with? She's not paying attention.
I labeled it backwards. I said order handle instead of handle order. Okay. So now, how does the data flow? Corey?
Right.
So we're going to have something that's going to flow to the customer, and what's that going to be?
Oh, the relationship?
No. This is the data flow. What information is going to flow on this arrow?
The order?
Very good. What information is going to flow on this data flow? Well, we'll just leave it for the order for right now. We don't know if it's going to be anything else. Okay, now the price file is going to send pricing data to the order handler. So, what is the price? Where's the price data come from?
The price file.
Yes, which is a,
Data store.
okay, and we draw that
As a rectangle.
sideways U with an extra bar. I haven't done this for 10 years and no, 99, that's 18 years.
I've never done this.
But you're not going to be able to say that for a whole lot longer. Okay, so what flows here? What?
No,
What flows there?
no, it's, yeah, because it's you. It's the side
Very good. Okay. The order the handle order, there we go, sends billing data to generate the invoice. So we're going to send what to where? We're going to send billing data to an invoice, a process that's called generate invoice. Alexa, what's a process look like?
Mattress.
I love that term. It does look like a mattress, doesn't it?
Not the way you draw.
What, Hannah?
It was like a sleeping bag.
Sleeping bag? Okay.
I didn't say anything.
I thought you did. You sure it wasn't you?
I'm positive.
Who was it then?
Lauren.
Did Lauren show up? No, she didn't show up. Okay, what flows here? It's the name of the whole thing right there. Okay. This makes it so easy. Golly gee. Okay. So what does the invoice generator do? Okay. So what do we have then? So we have an output line. Woohoo! That was hard. Okay, the next step. It also sends an open invoice data to the invoice data file. Chloe, how do you draw a data file? Okay, and when the customer receives the invoice, he or she sends payment to where?
And the payment process.
Has anybody copied this down?
Just wait.
I'm taking a picture. Let me get my
Okay,
out.
so Isaiah, come on down. When a payment is received, the handle handle payment process sends an invoice query where?
Invoice query gets the invoice file.
Yep. We'll just erase the open part. Well,
as well, or yeah, my bad.
here's an eraser. Now look at your fingers, it'll be pretty and black.
So,
Let's, we're gonna maybe cross things, so let's go up and,
You don't understand this?
okay, so the payment, or an invoice query, the payment, handle payment, sends that to the data file. Which direction's the flow? Ah, I was wrong. So we are going to draw another. This is going to be open still. Okay. So now we're going to create a new data store. No, that's a process.
That's this one.
Yep. Only put it over top of, put it over there over top of handle payment.
Okay. So that would be invoice query.
That'd be the invoice file. And what's wrong with your symbol? And? No.
Mine?
No.
I don't know. I'm sorry.
It's closed.
Look at yours, look at mine.
Oh.
Here's the
My-
eraser.
I don't know why. My apologies.
No, it's okay, you're learning.
Yeah.
That's why I brought you up here, so you can be embarrassed in front of everyone like the next person's
Yeah.
going to be. Sam. So we have a data flow. Where does the data flow from? To. So we're still here.
You have 3 minutes.
So we're going to have this, and it's going to flow from handle payment to here. So we're going to have an arrow from here to there.
Okay. So we're gonna have an arrow from
Handle, no.
no from here to here.
Yes, in the
Okay.
middle, in the middle. There you go. Now, and it's going to be called,
Invoice query between here.
yes. Sam, come on up.
Why is there an invoice file data store and an open invoice data store? Shouldn't they just be
That's a
invoice
good
data
question. Let's see if we get there. Okay, so in response to the invoice query, the invoice data file sends open invoice data to the handle payment process. So it might be what? What do we call that use of words that are this same words mean the same thing or something different? Semantics. Semantics. Semantics will get in our way frequently in this process because somebody's going to refer to something one way and then they're going to refer it to it in a different way, and we're going to say, wait a minute, you just called it this and now you're calling it that. Are these different things or are they the same things? So,
Everybody just gets up on it.
So your assignment, since we're out of time, is to take a picture of this and figure it out. Yeah. And submit it to the next.
We already did our homework for the week.
Guess what? You get more.
No, I already did all my homework. That's great.
Didn't we do them like Sunday?
So right here,
Being serious.
you're going to submit that. So right here.
Does anybody want to help me with homework this weekend?
Did I be Friday or Sunday?
I'll literally say
No, Sunday.
Sunday. Sunday.
I will hand out my.
It is due. What day is today? Monday. We'll pick up here Monday and we'll continue to march through DFD. So, okay, so. Okay, in addition, I want you to do all 3 of the DFD assignments.
Why? Good question.
That's it, because I hate you so much.
I won't even do that. Hey, Alex.
And we have to come tomorrow, so.
You should make it due Wednesday. Yeah. Please.
You should move next week's assignment to
Because
Friday.
I won't even be here this weekend.
Okay, it's due Wednesday.
Thank you. You're the best. I won't even have a computer this weekend.
Oh, the other class. Oh.
Wake up.
Hannah,
What?
Hillary, class is over. Right there. So that's on, that's right here. Lecture for the whole class period on half the chapter. It would be good. It would be good. It would be good.
See you next
No. Talk to Tyler though. That's right in front of you. Tyler, right there. That's his class. Let's see where he sits. I'm pretty sure he sits in the same place. Yep. So you sit there, he sits here. He's doing the first half. Yes, you need to know where he's going to end. So you will know. His email. Is it here? No. Rick. other new Marshall buttons.
It's not exactly challenging the stereotype. It's built in a way.